Alright, and welcome back here to another video on Node.js and specifically looking at the GraphQL section. So once I know what GraphQL is, which is a query language that allows you to build front-end and back-end application, that it is a new way of how do we interact with APIs and how do we build front-end and back-end. The beauty of this is that we can see how all of these different pieces of data in our server relate each other. So in GraphQL, it all starts by describing the data using schemas and ask for the data using query. So queries, GraphQL queries, they're good and they are marvelous. And the reason is because the GraphQL query really match closely what the returning object will get, we can predict what our query will return. And that includes all the property regardless how the data is stored. And the result is a JSON object with the data that we asked for. So that's great because that was the entry point of looking who made this tool, Facebook in 2012, and they unapologetically create that for front-end developers to solve underfetching and overfetching. These two particular issues where we have on RESTful architectures. This is the way of how do we build APIs using this RESTful. And one of the issues is that querying multiple collection of values or querying multiple collection in our server, we spend unnecessary additional requests / time to querying these different collections and then compose that on the browser so we can show the relevant data to the user. So this is the underfetching issue. And the other is the overfetching, because now when we make a request to a collections, we get huge amount of unnecessary data that also we need to filter out in the browser. So GraphQL solves this by only having one single entry point where you can make requests or asks for the data that you want, and you hopefully get that. Now, this is something that the best way to learn something is by doing it, and that's exactly what I did over the last couple weeks. And see first the advantage and the disadvantage of using GraphQL versus RESTful. So no more overfetching, no more underfetching. It provides types and schema, which aka you have a self-documented API, and speed up the development process. The trade-off is that this flexibility adds complexity. It is a new way of building backend or API specifically, and since this is not REST, this is another disadvantage, especially for most developers that are familiar on how to build a RESTful API. And the other is that catching is something that is difficult. This is an advanced topic that it go beyond the scope of this talk, but it's important to understand that with RESTful we already have proven mechanism to do that, but with GraphQL we have a particular way of doing it. So that lead us is to know and see to get first-hand experience how can we create GraphQL queries and using graphical tools that would allow us to query a GraphQL server where In there we can see is all of the types that in that GraphQL service exposed, and then see how it works behind the scenes. So that is looking at how can we perform a request to the GraphQL server using the HTTP protocol, right? Specifically HTTP post request that hit that GraphQL endpoint with the body contain all the necessary fields that we want, that we ask for. And, well, the server responds with our proper data. So then I look at how can I create my first GraphQL server, and it was very, very illustrative because using Node and Express, this web server, and the Express middleware, okay, from GraphQL, I saw how can I create this GraphQL server, and I started to see how can I define is the capability of this service using is GraphQL npm package and define is a type system where it will. This is where you describe is the capability of this GraphQL servers that is used to check if a request is valid, determine the type of the return, or determine the type of the result, and check if a value of a variable is valid when we receive that at request time. So in other words, is something like this. So look at the GraphQL specification and understand that the type system here. This is the type system extension, description, the schema is particularly very clear. It's the type system. What is this? The GraphQL type system describes the capability of a GraphQL service and is used to determine if a request operation is valid, to guarantee the type of the response result, and describe the input type of variables. And describe the input type of variables to determine if a value provided at request time are valid. Okay, so knowing this, okay, and creating our first GraphQL server, then I look at how can I create a more realistic GraphQL server, designing an e-commerce, because deep nested objects are very common in any e-commerce application or any application with some technical depth, which makes them perfect candidate. And it is amazing how easy it is to query really complex data structure to get the data that we want. So our API now is organized in types and fields rather than input, just like a RESTful API, right? So then, to make our application much more scalable, maintainable, modular, easy to maintain, to read, I look at this npm package called GraphQL tools, and this is just to answer a couple questions. Is that how can we break down our types into multiple files? How can we organize our server, their features, and how can we structure a server when we need to add more complex data to fetch? Uh, when we need to add more complex logic to fetch our data, in this case. So the way of doing that is using tools like GraphQL tools that under the hood Apollo use that, And once I learned this GraphQL way of doing things, specifically on how can I create a more scalable GraphQL application, I saw that there are not only the specification, which is here, okay, but also front-end tools for front-end frameworks like React, like Relay.dev, for example, Relay.dev, okay, would allow you to use GraphQL on the browser and a more high-end product called Apollo. There you go, like Apollo GraphQL, which allow you to build front-end and back-end application. So to understand that, that's one of the reasons why I need to dive into how I can create GraphQL server from scratch by relying on tools like GraphQL tools and modularizers or applications with schemas. Defining is a folder where you have is the GraphQL files when you define all of your types, okay, queries and all of your different types, and rely on package or a function called makes executable that what allow is or that what accept it takes the entire array, type array here, okay, and using a log file sync again from the GraphQL tools. What it does is to by receiving is the pattern or the glove pattern where it's going to look up for all of those GraphQL file extension and then load that to the next executable function here, okay, from the GraphQL tools. Again, this approach makes sense if your types are well defined and there's no name conflict. Okay, and then I saw how can we modelize our application is with uh, with something called resolver. This is resolver, which this is another component in any GraphQL server. You have schema and resolvers that they determine the value of a property once a GraphQL once a valid GraphQL query is being done to your server. Okay, so it all starts when the GraphQL servers detect an incoming request. If it is valid, they execute that query, and during that execution, to determine the value of a property, there's a function called resolvers to do that. So when you create your query, each one of those properties are execute the proper resolvers, not the server side. Once all that resolver has been called, then the server wrap up and send back to the client. So, okay, okay. So after I saw how can we modularize our application with schemas, also with resolvers, by looking at the project structure where we define is our GraphQL files per features, okay? We define is the resolvers, okay? And we are going to do pretty much the same as what we did by loading is all of the GraphQL files, but in this case with our resolvers. Now, Inside of the resolvers, we export is this model with the GraphQL uh, query, right? Where the anatomy of these resolvers, which is their argument, Hence is the root value that is being used will be passed to the root value. The argument uh, is being used when we have parameterized queries. The context is the data that we share all across different resolvers. For example, if we want to pass authentication data about which user login in different resolvers or for all of our resolvers, and the info that contains data about the current state of our operation. So the reason why we encapsulate this into or in its own file is for uh, scalability. And one of the great things of resolvers is that this allows us to perform API callbacks. So we did a couple of examples on how can we implement filtering with queries and resolvers by passing is arguments to that query and see how can we make use of them. All right. So it all starts by defining is the query in your particularly GraphQL file extension. Then on the resolver, define that proper resolver query to perform now that async operation. But because we want us to make our resolvers thin as and small as possible, we abstract that logic to perform that. We abstract the data layer logic into the model.js, into this file when it goes to perform all of this communication. So for the sake of example, we just only uses the in-memory list of products, right? And export that as a model, all these data access functions. Okay. I also look at how can I query product by ID, okay, to get only specifically one element for that, and then because so far we have seen how can we query data and how easy it is to do that. I also look at that in any GraphQL application or in any backend application, there's something called crew operation: create, read, update, and delete. So far I see how can we read data and how is the way of doing all of the other operations: create, update, and delete in a GraphQL way. So all APIs getting existing data and reading it is probably the most common feature or thing you're gonna do. So that's the reason why GraphQL focus on doing queries really well. But any real life application, okay, but in any real life backend application, okay, exactly. But any real life backend application, that's right. Yeah, but in any real life backend application, we need support all for crew. I mean, I guess. But in real life backend applications, we need to support all of this crew operations. So mutation is a way of how do you change or mutate the state of the application. Create, update, and delete. All right, and again, this is part of the type root level operation that you can do in any GraphQL set. Makes sense. Makes sense. So another root type level operations are subscribers or subscription specifically. We can see that here. Root operation type, query, mutation, and subscription. And queries are mandatory, whereas mutation and subscriptions are optional. So in our case, I just want to look at how can I implement a mutation. Pretty straightforward. Back in your GraphQL, where it all starts, you define is the type mutation, okay, and you set what will be the mutation you want to do. In our case, add a new product or uh, add a new product and add a new product review. Okay, cool. So I just start with the add new product here. Define is the name of the mutation and the argument that it needs to as the return value, which is from API. This is a common fairly pattern. It's a fairly common pattern to return the type or to return that object to indicate that it was safe. Okay, so then what's come next? Looking or setting up the mutation in your resolver right below your query, since this is a root level operation. This is a map for an object that it takes the name of the mutation and the resolver. So what is the body of the resolver? Okay, again, because we want us to make our application as thin, as simple, and small as possible, specifically this resolver file, we're going to, in this case, with add new product, we're going to define a function in the data access layer, the model.js, and pass the proper arguments. And on that layer, we're going to define all of the logic to create a new product. Okay, so this making our resolver independent to whichever model we want to use or any other implementation or database. Okay, it follow is the high cohesion low coupling principle. So cohesion is the degree uh, or is the relationship within that model, is the degree of relationship within that model, and the coupling being is the degree of relationship between models. One of them, cohesion is the relationship within the models, and coupling is the relationship between models, and cohesion is the relationship within that model. So all of these data methods are unified or have the same responsibility for that class. In our case, in here, okay? I'll argue that for more scalable application, okay, they're going to divide this query and mutation in their own file as well, uh, because you can quickly pollute this fast as possible. Yeah, you can quickly pollute this fast as possible. Okay. So, in our data access layer, okay, aka in our model for product.model.js, we define is the add new product logic, right? In our case, something like this. Specifically, this change for a more realistic example like this. And this is for adding a new product. Exactly. This is for adding a new product. That's right. So okay, this is how do we implement, how do we add a mutation in a GraphQL cell. So how do we expand the capability to mutate the state in our application? Then I look at a new exercise and how do we add a new problem review, okay? And specifically, how we're going to practice how to write mutation, and towards the end of the video, dive deep on how mutations are executed and how to execute many mutations at once. So look, the TLDR is that after I design again, uh, since we define here a new mutation, which is the add new problem review, all right, it all starts with our type or GraphQL schema, okay? We indicate what are the properties that it needs to, the return type. Then we look at the resolvers where we define is the name of the resolver as the resolver function. Call that function that takes care of the logic on how to add new product review. Okay, and in that layer, this is where we handle how do we add a new product review for that. In our case, we're taking is the in-memory list for the product by ID. You remember here for this product by ID, all right? And check if that match product exists. Well, we're going to add that new product review for that, and that's all. Again, this is we're not considering another edge case so far, but for debug purpose, at least we're considering is this scenario is match product. So good. And in our graphical, we define is seminal mutation here. But what happens when we define is those seminal mutation? We need to add an alias for that, just like in this example. So if you want to perform several mutations, and mutations are performed in series, one after another, so if you want to make multiple mutations on different uh, products, in our case, so you have to make an alias for that, like show review and jacket review. Okay, okay, good, good. Uh, so this is to understand and also talk about the thing that you have learned so far with GraphQL and from the entire Node.js course, right? Let me connect this. All right, that's right. There you got it. And with Node is here, and then you gotta jump to GraphQL and here. Okay. So now I'm going to look at the GraphQL with Apollo and building a server with Node.js. All right. Yeah.
Welcome back. We've been building our server and feeling really good about our GraphQL. But someone comes along and asks if we know Apollo. And can we work on an Apollo GraphQL project? We pause for a second, but we remember that we're ready for this. All right, what's the first thing that we need to know? Well, what exactly is Apollo, and how does it relate to what we already know? Apollo is another GraphQL implementation.
Mhm. GraphQL, Apollo, right? GraphQL with Apollo. So Apollo uh, is the industry standard. Is the industry standard GraphQL implementation? Is the industry standard? Is the industry standard of GraphQL implementation? Uh-huh. Funny thing here is that with any specification, there must be an industry standard for that. Why? Because this is something that can scale that. This makes scalable for that. For any specification, there must be an industry standard for that. I will argue this. For any, so for example, you have is the HTTP specification. Uh-huh. And the HTTP standard. The standard port. Semantics. Resource and specification. Okay, this is the resource and specification. Interesting. The WebSocket protocol. Okay. And the standards. Internet standard. HTTP semantics. Catchy. HTTP 1. Proposed standard. Proposed standard. Mhm. Additional HTTP status code. Uniform resource identifier. Living standard. Okay. Living standard. What about WebSocket? What about WebSocket? WebSocket protocol. Even though each one of those specifications has their own standards. HTTP semantics. Ah, well, okay. Okay. HTTP was further specified in the early 19th. Design with extensibility in mind, it has seen numerous additions over the years. This leads to a specification being scattered to numerous specification documents. But again, that, you have the semantics. You have that specification and a standard. You have a specification and then a standard. And an industry standard. This is actually the whole internet. Client server message, user agent, audience server, intermediate, catch, example message, exchange, identifier in HTTP, URI reference, HTTP related, authoritative access. Content encoding, compressed coding, display coding, GCP coding, content language. On the header, maybe, validator field, representation data and metadata, representation data. Talking about the content type. Content type, content encoding, content language, representation data, metadata. ETAG, methods, overview, common and method property, safe method, independent methods, definition, and trace. Request context field, response context field. So, for example, GraphQL is rely on making HTTP post to a GraphQL server, from the client to server. In This is a wrapper inside of this, or this is a wrapper from the HTTP protocol. Authentication scheme, parameters, challenge and response, credential, establishing a protection space, authenticated client and proxy, content negotiation, content negotiation field, conditional request, precondition, evaluation of preconditions, when to evaluate precedence with preconditions, range request, range unit, range, exit range, content range, partial put, media type, multipart, byte range, status code, overview of status codes, informational 100, hexagon the status code, and extending HTTP, security consideration, establishing authority, risk of intermediary, attack based on files and path name, attack based on command, code, and code injection, attacks via protocol element, attacks using shared dictionary comprehension, disclosure of personal information, privacy of server log information, disclosure of sensitive information in Unity, application handling in the field name, disclosure of fragment after redirect, disclosure of product information, browser fingerprints, validator rotation, denial of service, attack using range, authentication consideration, IANA consideration. Okay. Browser fingerprints Fingertipping is a set of technique for identifying a browser. It's for identifying a specific user agent over time through its unique set of characteristics. Feel. Again, this is somewhat helpful to look at to understand, but it's just to wrap this concept that I see here that Apollo is the industry standard for GraphQL implementation, providing the data graph layer that connects mother apps to the cloud. Okay, providing the data graph layer, providing the data graph layer, providing the data graph layer that connect that connects mother apps, yeah, it connects mother apps to the cloud. Apollo's industry standard of graphical implementation providing the data graph layer, the data graph layer that connect mother apps to the cloud. When you talk about data graph layer, is that layer of the data that contains from a numerous places, for the data graph layer. It can come from APIs, serverless, you name it, right? Mhm. First, a better way to do APIs. All your data managed in one place. Suited, suited for modern architecture, build great experience faster.
very much like Facebook's reference implementation that we've been using so far. However, Apollo is much, much, much larger with more features. It has all of these different libraries to make GraphQL queries and save GraphQL data in React on iOS, as well as Android. There's a server component, which is a replacement for Express GraphQL. It works very similarly, but adds some extra features if you need them. And there's a few more advanced tools that the Apollo team has built if you really want to commit to their platform.
Mhm. There are some more advanced features if you really want to commit to their platform. Apollo Federation implement a single data graph across multiple servers. Apollo Studio, building your graph with your team, evolve it safely and keep it running smoothly. And Rover CLI. Manage your studio graph and schema from the command line.
That help you build Apollo projects as part of a much larger team. But the two main components of Apollo
Mm-hmm.
to their platform, you need them. And there's a few more advanced tools that the Apollo team has built if you really want to commit
There's some more advanced tools if you really want to commit to the
to
platform.
their platform that help you build Apollo projects as part of a much larger team.
Scalability that help you build GraphQL projects.
The Apollo team has built if you really want to commit to their platform that help you build Apollo projects as part of a much larger team.
If you want to build GraphQL projects as part of a much larger team.
The Apollo team has built if you really want to commit to their platform that help you build Apollo projects as part of a much larger team.
That help you build GraphQL projects as part of a much larger team.
But the two main components of Apollo that you'll see in your development career are this Apollo server and the Apollo client, which is where we'll start because the client is where
Apollo. Mm-hmm. Graph OS. Apollo client and Apollo server. Mm-hmm. With the GraphQL, with the data, with the data, with the graph, with the graph data layer. Yeah, because it can come from different source now. Because it can come from different source completely. This can come from different source: review, product info, shopping cart, likes, inventory. It can come from different source. Mm, It can definitely come from different source. Like that. Mm, Apollo client, you have from the web or iOS or Android. Yeah, they have the industry for payment. Aside from other UIs, community driven. Mm, Catch normalization. Catch a new application never had. Modernized legal payment with GraphQL at PayPal. Yeah, and if they come from different sources, it's something like that. The activity. Mm. Again, this is the Apollo client, and the other is the Apollo server. Apollo Server 4 is generally available. Apollo Server is an open source, spec compliant GraphQL server. Spec compliant. Industry standard, spec compliant. Now, how do you say compliant in Spanish? Uh, Obediente. Uh, spec compliant in Spanish. Apegado a las especificaciones. Spec compliant, apegado a las especificaciones. Spec compliance. Spec compliant GraphQL server that's compatible with any GraphQL client, including Apollo client. It is the best way to build a production-ready, self-documenting GraphQL API that can use data from any source. Exactly, that can use data from any source. REST API, microservice, database, or any others. You can use Apollo server as the GraphQL server for a subgraph in the federated supergraph. a standalone GraphQL server, which is something that you do, or add to your application existing Node.js middleware, such Express, AWS Lambda, or Fastify. It is funny. They use Fastify for that. The service implies lower. A very responsive under load and happy users you can efficiently handle the reset of your server knowing that your server is the highest number of requests possible. Will sacrificing security validation and heavy deployment. Inspired by Happy and Express. For purpose validations and we have large projects of OpenGS Foundation. Yeah, but I'm going to rely on Express, my friend. Yeah, thanks for you. Thanks for you. But right now I'm going to rely on Express. What the? Yes. Yeah. You're going to rely on Express, my friend. Yeah. Totally, my friend. Totally, totally. Fast and opinionated minimalism, my friend. Express 5 beta documentation is not available. Ooh. JSON static route and URL application. Request and response. Oh, well, this is getting started to that. Okay. No, but it's okay. So with Fastify, Express, Express middleware. Exactly. And again, the thing here on this video, we're going to see we're going to see what is Apollo, which is this industry standard of GraphQL. Okay, Apollo is the industry standard of GraphQL implementation, providing the data graph layer that connect mother apps to the cloud. There's a lot of jargon here, right? But when you mean is the data graph layer, is the possibility that as we look at resolvers, now we're not only able to connect to database, but also to other RESTful or to other REST API, microservers, or any other implementation, okay? While receiving is the data from the different source, like the web, iOS, or Android. The vast majority of them. The vast majority of them. So you can use Apollo server as the GraphQL server for a soft graph in the federated supergraph. Okay, a standalone GraphQL server, which is another way of doing that, or add on to your application existing Node.js middleware, which is Express, AWS Lambda, or Fastify. And they tell you how to do that here by using the standard even with Nux. The logic community maintains the following open source integration for Apollo server even with Nux, my friend. Interesting. The Apollo server 4 includes Civil integration. Star standalone server and express middleware. The star standalone server function set useful defaults to get started quickly. Under the hood, the star standalone server function uses Apollo Server for express integration. Mhm. It has express middleware. The express middleware function is Apollo Server for express integration. Interesting. And Knox as well. Apollo Server integration for H3 and Knox. You can easily integrate Apollo Server with your H3 or NOC 3 application. Mm. Apollo Server, start server and create H3 handler. Create your Apollo server, specify the server option here, and the default start server and create 3 Apollo handler. Option specify context. Use which uses with A3. Create app to no listener. Create app with use API start server and create X3 handler. Okay. Okay, so that from that API endpoint, you specify that. Okay. Clone this repo, enable core pack using this. Mm, okay. Okay. This is something interesting, by the way, that I can apply this with others integration. With Nux. Okay. But let me look at how they do things here. Right. So Apollo Server provides a straightforward setup so your client developers can start fetching data quickly, incremental adoption, enabling you to add features as they need it. Universal compatibility with any data source and build tools and any GraphQL client, production readiness. Enable you to confidently run your graph in production. Okay, so the way to do this, not here, is using the express reference is this. This API reference document Apollo server for express integration, the express middleware function. In the example below, we use top-level await call to start our server asynchronously. Check out the getting started guide to see how we configure our product to support this. Express middleware function able to attach Apollo server to Express. Mm-hmm. They act as a middleware, express middleware. Express middleware function is expected to set up HTTP body, parsing, and course header for your web framework. Okay, interesting. As shown below. The express middleware function accepts two arguments. The first required argument is an instance of Apollo server that has been started, and they expect you to set the body parser on the course. Mm. Note you must call server.start on the Apollo server instance before passing the instance to express middleware. This is another way of how you can define this as well. In your Java, which is the entry point. To ensure your server grateful is shut down, we recommend using the Apollo server plugin drain HTTP server. Mm. Type def and resolvers. Uh-huh. type def and resolvers. Exactly. And they teach you things that are using in the standard. Okay. Okay.
Apollo's benefits really shine. Apollo Client is a set of front-end libraries that help make GraphQL queries and save
Okay. The Apollo client here.
GraphQL data in your front-end. Front-end libraries that help make GraphQL queries and save GraphQL data in your front-end.
Mhm. Content library that helps you save data on your front end.
Using Apollo is much more convenient than making post requests to your GraphQL endpoint on your server directly. It lets you
Exactly. Using Apollo is much more convenient rather than making HTTP post requests to your server.
query your GraphQL server and make GraphQL queries requests to your GraphQL endpoint on your server directly.
To your GraphQL endpoint directly.
It lets you query your GraphQL server with your front-end application, much like you would through Graphical. And it comes with added benefits like caching your queries, handling
This is from the Apollo client. It works much like using works much like defining a GraphQL query. It works much like defining a GraphQL query.
loading states and errors, and keeping it graphical. It lets you query your GraphQL server with your front-end application, much like you would through Graphical.
Mm-hmm. Much like you will through Graphical. It allows you to query your GraphQL server much like graphical.
And it comes with added benefits like caching your queries, handling
And it comes with some other benefits
loading states and errors you would through Graphical.
like catching.
And it comes with added benefits like caching your queries, handling loading states, and
Catching your queries, handling loading states,
errors, and keeping your data synced with the server. It makes the data that you fetched available to your front-end components, whether you're using React or Angular, much like you would through Graphical. And it comes with added benefits like caching your queries, handling loading states and errors, and keeping your
handling loading state and errors.
data synced with the server.
And keeping your data synced with the server.
It makes the data that you fetched available to your front-end components, whether you're using React or Angular on the web, iOS, or Android. It handles connecting your components with the data that comes back from a GraphQL query. without having to hook things up manually. That's Apollo Client. What about Apollo?
This is the Apollo client, right? Then the Apollo server.
Server. Apollo Server is its own package on GitHub, which allows you to create a GraphQL server in Node, very much like our Express GraphQL package.
Fuck.
Which allows you to create a GraphQL server in.
It allows you to create a GraphQL server in Node. Okay.
Node, very much like our Express GraphQL package.
Like a GraphQL package. Very much like our GraphQL package. And I'm taking notes of the storytellers, the copyrighted content, because this is something that I can also apply when I'm going to explain things like that, or if I'm going to create a story about myself or something that happened to me. I can use each one of them properly.
But Apollo Server can work with Express or Koa or pretty much any other popular Node framework. Even better, it helps you run and deploy your GraphQL code.
Even better, it helps you to
or pretty much any other popular Node framework. Even better, it helps you run and deploy your GraphQL code.
It helps you run and deploy your server
code to server.
Your server code to serverless.
Serverless environments, like Amazon's Lambda service on AWS. And it includes functionality to help implement subscriptions in your server. Subscriptions are the third type of GraphQL operation. We had your normal read queries, we had mutations, and we have subscriptions, where subscriptions allow you to push updates in your server, AWS. And it includes functionality to help implement subscription.
It includes functionality
in your server, AWS. And it includes functionality to help implement.
Yeah, it includes functionality to help you set up
subscriptions in your server, AWS. And it includes functionality to help implement subscriptions in your server. Subscriptions are the third type of GraphQL operation. We had your normal
subscription in your server. Another root level operation.
Read queries, we had mutations, and we have subscriptions, where subscriptions allow you to push update.
Where subscriptions allows you to push data
from the server to subscribing clients.
Where subscription allows you to push data from the server to subscribe clients.
Much like push notifications on your phone.
Much like push notification in your phone.
Subscriptions are a very advanced GraphQL topic that's
Yeah.
needed much more rarely than mutations and queries. Now, all of these things are possible
No, no. It's not a pen. It's not a pen. It's not a pen.
with Express GraphQL, that package that we've been using so far. But Apollo Server wraps up all of this functionality into your GraphQL server and exposes it individually in a set of npm packages. There's this individually in a set of npm packages. There's this page on the Apollo GraphQL website which explains how to choose the right package for you. We have the batteries included Apollo server package that includes just about everything, but then we can choose some different options. There's Apollo server, included Apollo server package.
Okay, I'm gonna leave this course right now. And with that, I'll see you. I'll see you soon. Take care. Bye bye.